I have a lot of backlighting today due to it being the morning. We'll just have to deal with that for now. We'll just have to deal with that for now. Okay. Oh God, what? A duo stream with clean? Yeah, no, I'm not gonna be doing any Escape from Tarkov today. Okay. I gotta sweep the floor for a second. I was eating the remainder of my cinnamon chips and I just got cinnamon dust everywhere. It was a bad move. You have to keep a broom on hand just in case of cinnamon chip dust explosions. Maybe that'll help. Well, we provide something like init.vk, which will initialize all the Vulkan garbage. Well, probably, because we will have, like right now, we will have programs that draw stuff on the screen. Right now, those are OpenGL. I don't know if I want to deal with OpenGL in the future, so yeah, I don't know. We'll see. Have you reconciled the work you did on laptop and desktop? Yes, that happened Saturday. That was good. Okay. Because currently the lifting of constants block parameters from arguments to the parent procedure, the parent function, is a parse time operation. We could try moving that to type check time, but then things get weird because in cases like, we'll pull out our example from yesterday. In cases like this, the body of the procedure, or the procedure header itself can't be inferred until the arguments and returns are inferred, and the return declaration can't be inferred until R is properly declared in the constants block. So we would have to set R up before type checking anyway. We could add the multi-visit thing so that we do a first visit to do the steals, then a final visit to do the type check. But it's probably not worth building out this functionality for this case, because it's actually more efficient to make constants blocks set up a parse time action only anyway. We don't have to detect steals each time we infer procedure. This is probably minor in terms of wall clock time, but hey, this is how I am doing it for now. How's that for a comment? Comment. I wonder if the reasons web people call everything technologies is because deep down they do realize that all this stuff is really dumb, but they don't want to admit it. So if they keep saying that these things are technologies, they'll feel like advanced technology creators. Like, I don't know. It's so weird how they've adopted that terminology. I talked about people talking themselves out of success. It's giving you a kick in the butt to get started on your side project. Well, okay, that's good. I hope it goes well. Did I get rid of the getting things out of a queue, checking if they can be completed, and throwing them back? I mean, that is always a thing. No, that's... Well, I'm not sure exactly what you're asking about, but that basic process is the core of the compiler. That's just how it works. That's why you don't have to have header files. All right? But there were some cases of that are no longer necessary due to the restructuring that was completed this weekend, yes. So there's less messy, gross stuff involving that, I would say. How does one go about debugging crashes that player have in a shipped game? Do you have a crash handler that automatically sends you dumps? So Steam, for example, will send you crash dumps. Or it won't send them to you, I don't think. Oh, I forget how it works. Because they have some player privacy issue and stuff. But you can see histograms of where things crashed and whatever. But honestly, for the most part, we don't have crashes in our code. Like, there's probably some very low probability stuff, because when you push things out to millions of people, low probability things start to happen. But like, so when the witness crashes, it's almost always a graphics driver crash, like more than 99% of the time. And we honestly can't do anything about those. Those are like bugs in vendor graphics drivers. So, you know, hopefully the vendor notices their crashes and fixes it. So for that particular game, we didn't really need that kind of mechanism, right? You're supposed to test your game very thoroughly before releasing it, right? And not have a bunch of crashes that people run into. I said something about that I didn't like some part of it. That might be what we got rid of last night, actually. Why does the compiler work by trying to progress in the loop instead of determining the required order? Because determining the required order requires solving the halting problem. When you have compile time execution that can add code to your program, obviously. What is my thought on the future of integrated graphics cards? I don't really care. I mean, they'll get a little bit better over time like they have been. I don't know. Is there something that I'm supposed to be thinking about there? Yeah, Witness is all in C++ except for the shaders, which are in shader languages. Do I have some example of that? Example of what? You gotta be more specific when you type questions in chat, because I have no idea what you're talking about. Example, what was I even talking about that there could be an example of? The halting problems. Oh, no, like, look, there's compile time execution, and that compile time execution can add code to your program. It could decide to define things one way or the other. Okay, let's say there's a global variable, right? Like, you know, are we supporting OpenGL or Vulkan, right? Are we rendering with OpenGL or Vulkan? That's a global variable. That gets computed at compile time by the metaprogram. And depending on which one of those is defined, there's a huge amount of code that you may load and process that defines the rendering functions that the game is trying to call, right? So to know when your main of your game can compile, well, you need to know when the rendering function compiles. When that compiles depends on where you load it from, all right? Now, how do you know where you load it from? Well, if you could predict the value of that variable, you could know in advance. But that variable itself is being defined by compile time execution, which can be an arbitrarily complicated program that, for example, outputs a Boolean true or false, right? That program itself, in order to run that, has to be its self-dependency resolved and stuff. And so you have this thing where some amount of program needs to be able to run and then output a variable, and then more program needs to run. So you can't even, unless you knew the future and knew what the variable was going to be, you can't even do everything in one pass, because enough pass has to happen for the execution to happen, and then other pass happens. Hopefully that makes sense. Okay, so I want to put this back. But at least we know why it's there now. And then we put this, we take this out. Actually, we should be able to just revert this. Whoops. Come on. Yep. And then we're going to run our real slow debug mode tests just to make sure that we catch any assertions and stuff. If you can loop and retry stuff, you don't see how you couldn't have some logic to do it deterministically between runs. It's just not that simple. Like, okay, if you haven't looked up a particular variable yet, you don't know what type that variable is, right? Obviously. So it's just some name. You have some name, hello. You don't know what hello is. You don't know if it's an integer or a string or whatever, right? Okay. Somebody's calling f of hello. So until you look up hello, you don't know what f is, right? F might be one overload of a procedure. It might be a different overload of that procedure for a different type. It might be a struct for all you know, right? Because the syntax in this language for instantiating structs. So you don't know anything about the type of F, even though it looks like a function call. It could be a macro. You don't know anything about the type of F until you know what hello is, and then you can look it up, all right? Now, depending on what F is, the call of F itself may invoke compile time execution or not, right? It may, it may have modified directives, it may have a run directive in it, any of that. So I guess what I'm trying to say is until you know what hello is, like if your plan was, okay, we're going to make this time segment that goes from the start until the first compile time execution, figure out what all the operations are, and then order those by dependency, and then proceed in a solid order for all of those. The point is you don't know when the end point of that time duration is, because it depends on what the type of hello is, which you haven't looked up yet. All right. Does that make any sense? There are other people contributing to the compiler, yeah. All right. Whoops, that's the release compiler, which we still haven't rebuilt. This is the debug compiler. Bam. So we're going to run the tests. And we're going to build the game. And it should all work. Okay. Somehow I oversteeped my chai, and it wasn't even that long. Okay. Now this is the next one to attack. This could be not fun. We'll see. Excluding run directives, wouldn't the correct order be whatever order the looping finds stuff to do? But now do that without looping. But like, okay, so do the code that finds the stuff to do in the right order without doing the code that finds the stuff to do in the right order. Right? Have fun with that. What is the main? There is no main inspiration here. It's just this language is designed by solving the problems that I have from day to day by working in C++. Okay. Okay, so okay, I sort of did explain that in the other comment. Also steals okay, great. We caught the no check-in before we checked in. Just sounds like it should be able to construct something that gives you looping order for stuff that doesn't depend on runs. But it would probably be horribly complicated. It would involve... See, the problem is... You would basically need to write the type checker twice instead of once in order to do that. And then the versions would get out of sync with each other, and it would be a disaster. Would we partner with Unity? I don't even know what that would mean. I don't know what that would mean. Will you still go for the defer option? Maybe an alternative good solution would be to assign a function as a destructor of some data structure, something like RAII, but only for the destructor. Why? Why? And like once you start doing that, it doesn't really, like, you know, we sort of tried, maybe I could try this again sometime, but I sort of tried like a simple version of constructor destructor, and it doesn't really work. Like one reason why C++ is as crazy and terrible as it is that it actually follows some of these ideas to their logical conclusion, right? And I was trying not to do that. I implemented constructors in a way that was limited in extent, and it just wasn't very good. It added a lot of complexity to the compiler and to what you had to think about, and it still didn't really solve problems that well. So I took it out. And I'm happier that it's not here. So, well, we have a panic mechanism. I mean, you can easily panic by calling a library routine. So what? That's no big deal. What CPU do I have? I don't know. It's some Intel CPU. Panic is an exception-like thing in Go. Well, we don't have C++ style exception handling. So have I played Detroit? No. I have not played Detroit. Okay. Yeah, I want to go here and take out this remnant. Right here. Now this is probably going to cause, I noted that this caused a test to fail. I have no reason to believe that that won't still be true. So we're going to see, and then we can run that test directly and it won't take all this time. Wait, did I rebuild the compiler? Yeah, okay. I was spacing out for a second. If I encountered property testing, no, I have no idea what that means, but I am automatically suspicious when somebody makes up a new buzzword term. What do we use the build server for? It reports problems. So first of all, it makes executables that get shipped out to the team, right? Like people who aren't programmers. And then secondly, it tells us if there's a problem doing that so that we realize if we forgot to check in a file or mess something up. And it does that by running tests, right? But it's just these same tests that I run before I check in. So if everything is done correctly, then the server should not tell you about anything you didn't already know. Now it gets a little weirder if you're building multi-operating system builds and stuff, which we're not doing that right now. But if you do that, it is more likely like, oh, I changed this thing and it happened to break on Linux. Whoops, right? But yeah, it is what it is. I don't see anything breaking here. We'll see. It'll break at the very end. Is there a nice use case for C++ style exceptions where you can return the errors along with your return value? How about just returning the error along with your return value? And yes, we've had a thing for like 4 years that says people have to receive this return value from a function. You can go look it up. Is there a mechanism in the language to return an L value, for example, in an overloaded operator, so you can assign to it? No. No. Well, I mean, there is a mechanism to return an L value. It's called return a pointer to the thing. We don't do all the C++ reference value craziness. Wow, that actually worked. Are you kidding me? I guess we fixed what was breaking that in the process of fixing a different thing. Really? That's pretty good. Yeah, we can refactor and clean this up further, but I mean, I think I really wasn't expecting that to work. The problem with defer is you have to make sure you defer each time there's a function that deletes something. Well, but why are you returning, like, okay. Okay, let's talk about a core difference in philosophy. C++ has a certain idea of what it means to be high level, all right? C++ thinks that high level means that anything you do, like you can make a short expression like a function call or just a declaration of a variable or something, and that can unpack into an arbitrarily large sequence of events in a potentially unexpected way to the programmer, which is a downside, right? But like that's the design of C++, right? So like obviously if you have a function call, that function could be arbitrarily large in most languages, right? But in C++ it could activate a bunch of, for example, compile time mechanisms to add code to your program and stuff, right? I mean, I guess that's true here too. It's just a different way in C++. What am I trying to say? Okay, let me step away from the actual compiler part. Let's just talk about philosophy, right? In C++, the philosophy is being high level means that a data structure should know a lot of things about how to handle it. For example, here's how you allocate memory for it. Here's how you clean up memory for it, right? Here's how you close the file handle that it's using. And we should automate all that so that the programmer doesn't have to think about it. And that's what it means to be high level, right? I think that's a relatively uncontroversial statement. I mean, that's not all of what C++ thinks is high level, but that's an important component of it. All right. I don't think that's correct. I think that leads to sloppy programs that are slow and full of bugs, and I think that that's why we have seen what we have seen. So first of all, this idea that everything is an object that allocates and deallocates, A, means your program is going to be slow because dynamic memory allocation is slow. B, it means if you hide that stuff from the programmer, it means the programmer doesn't know what's going on, and therefore the programmer doesn't know why their program is slow, right? And then C, it means that things are not being designed in a way that the programmer is supposed to have a say in what is happening or how things are done, right? Let's take a more obvious, because memory allocation is something where, people who haven't done stuff with memory, who haven't tried alternative ways of doing things, think it's complicated and hard, because that's what the rhetoric is. It's not complicated and hard. Like in this language, most allocations are just on temporary storage and gets automatically freed at the end of the frame, and you don't even think about it. So you don't have to free things most of the time in this language, right? Like allocations, long-term heap allocations are only for things with a long lifetime, which is not most things, right? It's the same observation that people making garbage collectors had. Okay. Let's take a place where object-orientedness failed at these things in a different dimension, like rendering, right? Nobody who makes a video game engine now, or not nobody, because people do bad ideas all the time, but when you make a video game engine, you don't say, here's a bunch of objects in the world, and every object has a draw method, and you call the draw method to draw it. Why? Because that is how you make something that is super duper slow and unable to coordinate and batch things together so that they can actually go out in a timely manner to the GPU, right? So this idea, and because you might want to draw things differently depending on what's happening. So what if we're drawing into the shadow buffer, right? What if we're drawing into a cube map that's going to be used later in the main scene for reflection mapping? We may want to do different things in those different cases. And now, like, maybe every object is supposed to be aware of that. It doesn't work, right? Memory allocation is the same way. Saying that an object knows how to allocate and deallocate itself is very presumptuous. Okay? It means that you will be unable to coordinate things together later on and batch them and control them if you follow that line of thinking. And so now this is where C++ people's heads explode, because it's like, that's the only way they've ever thought about how to do things. And so it just seems like crazy talk, like impossible to not have objects control their own allocation. But like, there's all sorts of things about that. Like, first of all, most things don't need to dynamically allocate, actually, right? And then things that do, you want to know that you're dynamically freeing things, and you want to know when that happens, and you want to have control over it, right? And so that's where something like defer comes in, as it's convenient, but you know it's happening. All right. Maybe that's enough of a discourse on that subject. What is my approach for limiting memory usage in a job system? We don't really use a job system anymore. I mean, we still use it for parsing, but we're going to move away from it because I don't think a job system is that good of an idea. Casey convinced me that it wasn't, and I think his analysis is correct. So you can ask him for the first-hand analysis of why a job system is not a good idea. Speaking of allocation, if you want to pretend you have implicit context allocators, Do you think using TLS for that is an okay compromise performance? If you only query TLS when you plan to allocate, you think the perf should be fine. Yeah, if I were trying, so what the question is about, when you call the memory allocation function in this language, for example, it's not directly baked into the executable, right? It calls through a function pointer that's in a commonly manipulated data structure. So you can put a replacement allocator into this data structure and call out to like a whole library or whatever, and it'll get your new allocator, right? Kind of like the way vtables work in C++, but the good version of that and not the poopy version. So how would you do that if you were going to implement it yourself? Could you use TLS? I think so. Like, you wouldn't pay for the TLS except when you read the function pointer, right? And so you could pretty easily have your memory allocator call, just read the function pointer and call that. So, like we said, memory allocation is already pretty slow. So paying a little bit for TLS is probably not that bad in that case, right? So one thing that we do is like, hey, let's push a fast allocator. And then, that just linearly allocates everything in a pool, and we'll release the whole pool at once, and we'll call out to this library and do all this stuff, right? If you're trying to do that, then you might start caring about the TLS overhead, because you know. But I mean, that's probably what I would try if I were doing it in C or C++. Is it possible to name multiple return values? You were referring to job systems in general in games, for example, or do I think they're bad? And yes, I said job systems. I said we do not use job systems because they're kind of bad. Yeah, we're still going to parallelize the compiler, just not with a job system. You could probably cache the function pointer and be fine. I would just try it first. Like, again, this is a thing where, try it, benchmark it, and then see if it's a problem in that case, because it may not be. Like caching the pointer, I'm not sure how you would do that in a thread safe manner without taking more TLS overhead. So like, how do we manage memory in the witness? Just not allocating very much. That's what all game engine people do, is they just don't allocate that much memory. What do you use instead of a job system? Just classic parallelism. No, I missed the description of property testing. Do I think it's possible to test the mathematics-like invariant properties of certain functions? I mean, we already have that even in C++. It's called assert. We have that in C. It's called assert. So like, I'm not sure why you would make a different name for assert. The thing is, mathematics-like invariant properties of functions is a small minority of a small minority of your code base. So like, putting a lot of effort into that, of giving it its own name and stuff. I mean, unless you're writing a math library. If you're writing a math library, then maybe it makes sense. But like, for general programming, Says me who didn't watch Handmade Hero, or Casey just loads up 4 gigs of memory in the first 50 videos. No, but the point is he does that at once so that he doesn't have to call malloc a bunch, right? Or I guess he's trying to avoid using libc. But I didn't say keep the number of pages allocated to your program very small. I said don't allocate memory very much, by which I mean call into a heap allocator, right? He probably just loads that and then does a bump allocator, you know, which is fine. That's probably what I would do in some cases now. How do you approach limiting memory when threading stuff? Well, I have the same thing to say about that. Like, why are you allocating so much memory? I mean, here's the thing. Again, I say this all the time, and I can't say it enough because people don't seem to get it, right? Having parallelism, having concurrency at all is not that useful unless you achieve parallelism, because otherwise your program's just going to be slow anyway, right? Achieving parallelism is actually really hard. It's a lot harder than just making a separate thread that runs your code in another thread, right? Because you have to avoid synchronization between your threads, all right? One common synchronization point is the memory allocator, all right? Like if you have a bunch of threads and they're allocating memory and you have a programming language where, like C++, I believe, where you're allowed to allocate on any thread and free on any other thread and it's fine, well, those allocations and frees are all syncing on each other all the time. And that's going to prevent you from having parallelism. So you don't want that to begin with, right? So if you're calling malloc a lot in your job or whatever parallelism, that is already very bad. That is already gonna make your parallelism moot. Okay? So so there's that. And then there's the secondary problem where it's like, it sounds like you're hypothesizing that limiting memory usage kind of comes in the back end in some way. Like, I'm launching this thing. I don't know what it's going to be doing. It's going to be using an unknown amount of memory. And then I need to try to limit that somehow. Now, here's the thing. If you're going to be using up to the amount of physical memory of your machine, then now physical memory is a resource that you need to manage and allocate appropriately, again, in order to achieve parallelism, right? If your jobs are all fighting over physical pages because they're swapping each other out, you're not going to be parallel at all. Now you're syncing on physical pages, right? So, well, what's the deal there? Like, you need to, in a case like that, know how much memory is being used by what job or by whatever thread, and know that there's enough for everybody, or else, again, you're not achieving parallelism. And so it's like that design consideration needs to go in the front end. And this is another reason why the whole C++, like, I don't know who uses what memory, it just doesn't scale into the future, right? If you're going to write an efficient parallel program, you need to know where the memory is. That's just how it is. And in the front, you need to say when you start the threads, okay, this guy gets 2 gigabytes, this guy gets 500 megs, this guy gets 6 gigabytes, or whatever, right? Or it's not going to run correctly. For instance, stuff like allocating a chunk of memory for decompressing stuff when reading from a file, but you can't have too many chunks allocated at once. You can't always know how much to allocate up front. Why not? Why not? I mean, it sounds like you're trying to allocate the minimum amount. Why don't you allocate an amount that you know is sufficient in all cases and then don't touch it? Is pipelining the different passes of the compiler achieving parallelism? So some stuff in the compiler is parallel right now and other stuff isn't. We're gradually restructuring it over time to be more parallel friendly so that eventually we can get everything in parallel. But that's not the highest priority right now. Maintainability of the compiler is actually the highest priority right now. Like simplifying it, making it robust, getting rid of bugs, that's what we're doing. Because you're reading files that come from the user and you don't know what the file is like, it might require a lot of memory to decode. Why? In case of, so just, I mean, if you think a malicious file is going to require an unlimited amount of memory, I don't know what decompressor that would be that would require that. That doesn't give you that guarantee, but suppose there is one, just fail to open the file in that case. Just say, sorry, the decompression tables or whatever, I don't know if it's like a Huffman coding or whatever, but the Huffman tables are too big. We can't open this file. Like why would you cause opening of malicious files to make your whole situation fail, right? Making it robust and simplifying seems hard. Don't these two cases often clash? They do. They do, yes. Okay. So, I mean, when we last left off, we were amazed that I was able to just delete this thing that I thought was going to be scary. So we're going to run it in release. And still be amazed. And then check it in. Wait, did we check it in? Is that... Oh, we checked it in, didn't we? No, we didn't. All right. Remove another no longer necessary queue call. Yeah, that's great. I am so happy about this. Okay. So this is a renaming that we could do. It's kind of trivial and silly, but we'll go ahead and do it. Why aren't the tests compiled in parallel? Because we just don't do that right now. I don't know. We don't have enough tests for it to matter. Okay, so this is just that I did a thing in load directives that I don't think I'm thrilled with. This is a bad name. I'm going to call it insertion scope. This is the place where the load will put its declarations. Okay. So I'm going to delete those and make, I think we can delete all uses of these two variables and just make them insertion scope. We'll find out. Have the beta testers made me reconsider any design aspects of language? Not major ones. Small things come up all the time. Okay. Okay. Wait, and then we... Uh-oh. This might break something. This was a mistake because we didn't ever use it. Well, we'll see what happens. Oh. Wait, really? See, this is a little confusing. Let's just do this. We could break something real bad here, but it'll be fun. So there were sort of two, sometimes when code gets confusing, it's because something conceptually weird is happening. We were setting this module global scope. The reason it was called that was so that loads that create file scopes would know who to parent from. But then we were also using that later after that parenting activity as like the scope that we're putting stuff in, I guess. I don't know. It's weird. It was not clear. So all right. This is insertion scope. Wait, no, it's not. All right. All right. Let's just, okay, we're going to make this clear. You know what? This was fine. I just didn't understand. We're going to revert for a second. And we're going to name things better, and then we're going to make sure they're used correctly. All right. So we have this thing called file scope. I'm just going to give this a very long name. Like that. Like, if you don't understand, maybe your names aren't good enough, right? Okay. See, and okay, this thing here is not good. All right. And then, like, we didn't use it anyway. See, this is the, yeah. Okay. That's correct. That's correct. That's correct. That's correct. Okay. We'll rename it in a minute. Here, we shouldn't be doing this. Let's just say this always has to not be null. Okay. Probably somebody is violating this. Okay, this is correct. This is not correct. Not for the way I want to do things. Oh, let's, never mind. I didn't see we use it down there. All right. hate Emacs. All right. And what is this for? Override block. This is the scope into which all these things go. All right. This is not really right. So many things. All right, main. Okay. Can we leave the module global scope? No. I hope so. Let's find out what happens if we do. Pump. Yeah, this is not good. Okay, well, first I have to hit a Windows key that messes everything up. Are there closures? Nope, not right now. All right. No, that's release compiler. Oh, we built release compiler. Wow, okay. Well, now that said, we added some assertions and we want to check if they're going off, but otherwise, then this cleanup was successful. Can you use non-ASCII characters? Probably. Oh, wait. Right. We want to be running debug, not release. Want to make sure to exercise those assertions. Make sure they go. Okay, let me prioritize these other ones. That seems important. This we could do later. That's just the stuff I'd like to figure out sooner. Let's put that. I think this one we did. Yep, did that one. This is a later. Did that one. Okay. We passed, so small cleanup of load field naming. Let's put the struct there. All right. Bam. And the build server is successfully running, which, by the way, prior to this recent integration that I'd been working on for a long time, we had thread safety problems that Windows 7 was in some way activating. But now it's building and they're all passing, and that's great. Very good. What is my thought on software rendering? I think it is a lot nicer than trying to deal with GPUs, but it's also a lot slower. So what are you going to do? Glad you enjoyed The Witness. We worked hard on that game. Does ASAN work? I don't know. You probably could turn it on in some way. We probably just haven't hooked that up. Like something like ASAN, I'm not sure how confused it would be by the way we do memory. So, you know, we'll see. We definitely plan to have something for that that's easy to use. I don't think it would be a front end to ASAN itself because, again, our long-term plan is to get off of LLVM. So I think it would be our own memory checker. Okay, so this was a thing in the parser that I'm not sure about. So in the parser, we do all this pushing and popping of blocks because we set enclosing scope on things. And the thing is, do we need to set enclosing scope on things? Because right now that mostly gets set during flatten. If we can get rid of that, it'd probably be good. Probably save memory in the long run. Would I ever consider adding a compile target that would enable writing shaders? We've thought about it. I'm not sure that that's a compile target, though, as opposed to just like a user level library. We've thought about it. I'm just not sure how good of an idea it is in reality. It's unclear. Unclear. All right. So I want to look at who sets enclosing scope. There's a lot of people who do it here. But I think most of these can be set in flatten. And the reason, okay, there are many thoughts behind why I want to do this. One is it's confusing. Like when a node gets its enclosing scope, so, okay, why do nodes have pointers to their enclosing scope? Because sometimes you want to know what that is. So like when you're looking up an identifier, you need to be able to look from the identifier up the tree of scopes. And so the way we do that is by storing the pointer on it. Now, it's confusing that sometimes this gets set at parse time and sometimes it gets set at flatten time. And then B, as long as we do this in this way, it prevents us, or it makes it a lot more confusing to split the parse data from the post parse data, which is something we're going to want to do later, which will help with parallelism. So yeah. Well, we support compiler plugins. I mean, you could do whatever you want at compile time. It's fine. I wouldn't call that a plugin. It's just a library. How important do you think the idea of homoiconicity is? Not at all. I think it's a goofy thing. I think there's a reason most people don't use Lisp, and it's homoiconicity, honestly. Like, I mean, that's not the only reason, but it's one of the big reasons. You know, Like, it sounds like a good idea. Oh, let's make the minimal system that could represent blah, blah, blah. But that completely ignores ergonomic factors, like what happens in your brain when you look at the code. You know, how, like, if everything is the same pattern syntactically, then your brain's pattern recognition facilities are being thwarted, right? You have a lot of stuff in your brain that's good at syntax. And if you don't allow yourself to leverage it, that's a negative. And so, yeah, it's appealing in the sense that you don't have to write that much of a parser for Lisp. But guess what? When you're doing a good compiler, the parser is small. Like, okay, this compiler even, it's smaller than most compilers, and it doesn't have its own optimizer, right? The parser is 4,600 lines. That's less than 10% of the compiler. All right? So you're talking about changing your entire language for the benefit of saving less than 10% of the compiler. And that number will go down as we add optimization. Like, optimization can easily be more than half the compiler in the end. So you're saving less than 5% of your compiler, and you're making this language, it's not a good trade-off. You know? Do I find myself making compromises against my personal beliefs in order to cater to a broader audience? No. No, that's the difference between me and a lot of people, is I simply don't do that. You have a choice about whether you do that or not. It's not like unnecessary, or it's not unavoidable, I mean. The fight against this sometimes makes you really tired. Well, why are you, okay, why is there a fight though? Like, do you have to argue with other people that you're working with to convince them that what you're saying is the right way to do it, or what's going on? Lisp's lack of syntax is not about the parsing. It allows for code generating macros. That is false. It may make code generating macros easier to think about for you in some dimension, but it doesn't allow it. For example, this programming language has code generating macros, and it doesn't have Lisp's syntax, all right? So you have to at least question these things that people tell you. Okay? You have to question this and ask if it's really true. Now, you might say, well, it's not as easy to deal with because there's all these different node types in the syntax tree. But my answer to that is the lack of structure in the syntax is the reason why it takes so damn long to understand and debug Lisp macros, and why they eventually decay and nobody understands what the hell's going on, right? For the same reason that you want strong typing in your language that Lisp doesn't have, you want strong typing over your node types. That's just how it is. It helps you. Okay. What were we doing? I was going to go try to set and closing scopes on things. So, like here we assert that it's already set. This could take a while and be slow. Oh, wait, I have a note here. Let's read the note. If we require that the scope always be set before and further, and if someone submits a procedure with modified code, we would be requiring them to say, we don't have a scope. We set it to the flattened block. I don't like this. I don't like this thing that I said on January 3rd, 2017. Okay, what happens if I just set this? Let's just say if we have an enclosing scope, this will probably fire, and that will allow us to see in what cases do these things differ, and is it for a good reason or is it not for a good reason? Okay. What's the difference between lowercase c and capital C? Those are both macros. Lowercase c just copies a value, and capital C recurses because it's an expression value that needs recursion. Okay. Oh, that was fast. Oh, let's make. I don't want to have to do. We're going to do that so that we don't have to like interrogate the compiler all the time. Okay, so current and source and closing scope. Yeah, okay. So as I thought, so this is a thing that we maybe need to fix anyway. So the identifier was put in a file scope. But when we're calling flatten on this stuff, we're using the parent scope. And the question is, oh no. See, you can't, oh no, I think I know what's going on. Is this a declaration? Yep. Oh boy, okay, everybody. The way scoping works in this language is, if you've got a declaration in some file, right, it's any identifiers that it uses and stuff refer to the file scope, whereas the declaration itself may be stored in, or is probably definitely stored. Well, okay, depending on your scope settings, if you say, hey, we're scope export versus scope not export, the declaration gets put either in the module scope or the file scope, right? So you could have a declaration in module scope that is, the identifiers look into file scope, right? Or at least that declaration is found by looking up an identifier in module scope. Now, can we make it so that that still works that way, but the declarations in closing scope is not module scope, but is the file scope? And how do you think about that? I'm yawning already. It's nap time already. It's 9:53 a.m. Did I solve the assignment issue from last night? I don't know what the assignment issue is, but yes, all issues from last night are solved. Wow. I am yawning. What did I decide about checking the return type at the end? Checking the return type of what? Oh, that thing. Just, you can go see the VOD. We dealt with that at the beginning of this stream. I discuss the solution and why. I type a whole big comment. Okay. This could be, this is where I question if we really want to get into this now. Like sometimes, because this has to do with declarations and where they happen and stuff, you could end up in a situation where you start doing this and it's actually better if you do it after you clean up some of the other things on the list, because there's going to be less confusion and ambiguity that get in the way of debugging this. It's quite possible that that is the scenario we're looking at. Now, so in general, I don't like this whole, hey, it could optionally be set, otherwise it gets set to the outer thing, especially when the outer thing is module scope and not file scope. Like what's going on there? So I want to figure out this is not a very coherent explanation, but we're going to delete it soon. Okay, so this is one of those cases where it's hard to know for sure what is simpler or what's more complicated. Like right now, a declarations and closing scope is where is the name that's referring to this declaration. But an identifier's enclosing scope is where does the identifier look to resolve itself? And that's kind of the inverse of the first one. And since declarations really are mostly about do we need a declarations enclosing scope? I can think of at least one place where we might be using it in a way that maybe we shouldn't. Oh boy. Okay, usually we check the block type, which wouldn't change between file and module scope, and is more about, it's more about knowing, is this in an imperative procedure or not, right? We need to think about this. I'm kind of not in the mood to do this one now. You know what? I'm in the mood to sort of end because I'm yawning. I'm really tired. I think we're going to end the morning stream, and we may come back later today. Maybe I shouldn't have eaten a bag of cinnamon sugar pita chips for breakfast. Maybe we're sugar crashing. Yeah. All right, everybody. We may be back later today. We're going to take a break. When we come back, well, maybe I'll have decided not to do this. Like we've just got, so sort of what's going on the menu is we've just got all these cleanups that are fallout from this big thing that we did. And we're just going to do them in the order that makes the most sense. And if this one doesn't, we'll do other ones and we'll come back to it because there's no real hurry on any of these. All right, taking a break. I'll be back later.